Hello students, in the last class we have completed about the concentration dependent electrode potential, that is Nernst equation, for both for a single electrode as well as for a cell. Now we'll move to the next concept, that is relation between electrochemical cell and Gibbs energy, as well as relation between equilibrium constant and Nernst equation. So now first we'll discuss about the relation between equilibrium constant and Nernst equation, or simply we can derive the equation for equilibrium constant from the Nernst expressions. Look at this. So here the relation between equilibrium constant and Nernst equation. For any galvanic cell, if you're considering any galvanic cell, the Nernst equation is given by E cell is equals to E naught cell minus 0.0591 by N, where N is number of electrons involved, into log of oxidized state divided by reduced state concentrations terms, where this N is number of electrons involved, it is different, and this values we have written at the temperature. If temperature is equals to 298 Kelvin, that means 25 degrees Celsius, and we have substituted the value of R and F, Faraday's constant and universal gas constant, and we have solved. It is simplified. Now concentration of oxidized species divided by concentration of reduced species, where this N is number of electrons involved, it is different. So these values, it also varies, right, for galvanic cell. For example, if you consider for a Daniell cell, because we have used this Daniell cell, for this cell Nernst equation is given by E cell is equals to E naught cell, where what is the value of this E naught cell? E naught cell is nothing but cell potential at unit concentration. That means if the concentration of the species involved in the cell is 1 molar, then the cell potential is taken as naught, E naught. So for Daniell cell, electrode potential at a different concentration is given by E cell is equals to E naught cell minus 0.0591 by 2. Why its value is 2? Because 2 electrons are involved during the oxidation, or you can consider the reduction, into log of oxidized species, because in Daniell cell, as you know, that zinc undergoing oxidation. So this is oxidized species, Zn plus 2 ion, oxidized species. Similarly, Cu plus 2 undergoing reduction. So this undergoing reduction, reduced to Cu. So oxidized by reduced. Product side by reactant side, क्योंकि नेट रिएक्शन में ये प्रोडक्ट साइड में रहते हैं, ये रिएक्टेंट साइड में रहते हैं. द नेट रिएक्शन फॉर द Daniell cell is Zn plus Cu plus 2 gives rise to Zn2 plus copper. So this is about Daniell cell. So here we can find this is the negative, that is minus. If you want to change into plus sign, so by changing this denominator into numerator, so mathematical term log A by B can be written as minus log B by A. So what is that formula? So here we have the formula log A by B can be written as minus log of B by A, right? Log A by B can be written as minus log of B by A. So here same. So that means E cell, so the value of electrode potential is directly proportional to concentration of copper ion, whereas inversely proportional to concentration of zinc. So यहाँ पर denominator में है तो inversely proportional ऐसा मत सोचिए. If we change these two values, zinc and copper interchange किया तो क्या हो जाएगा? It will be plus. So therefore E cell is directly proportional to copper ion concentration and it is inversely proportional to concentration of zinc ion. So here I have written, when the cell works, that is during the working of the Daniell cell, we can find that concentration of Zn2 plus ion increases. Is it right? Because zinc undergoing oxidation हुआ तो क्या होता है, Zn2 plus concentration increases and concentration of copper ion decreases, because these Cu plus 2 ion from the solution it get deposited on the electrode. कैसा होता है Daniell cell? Daniell cell के बारे में तो आपको पता है. So Daniell cell में copper electrode is dipped in copper sulfate solution. कॉपर सल्फेट सोल्यूशन में डिप किया थे, तो सोल्यूशन में Cu plus 2 ions are there. These Cu plus 2 ions are get deposited on this. When Cu plus 2 ion इसके ऊपर डिपॉजिट हुआ तो सोल्यूशन में इसका कंसंट्रेशन कम होते. So same thing I have written here. During the working, concentration of Zn2 plus ion increases, whereas concentration of Cu2 plus decreases. Right? So therefore, we can find here cell potential values also decreases. For Daniell cell potential values is found to be 1.1 volt, 1.1 volt for unit concentration. If the concentration of these two species is 1 molar, then the cell potential is 1.1 volt. Now, as the concentration of Zn2 plus increases and concentration of Cu2 plus decreases, cell potential values also decreases. And this reaction, when the reaction proceeds to certain extent and it stops, that means after some times when the concentration of zinc and copper ion remains constant, this indicates that equilibrium has been reached. So at the point of equilibrium, the cell potential values shows 0. That means at equilibrium, cell potential values is equals to 0, and it is possible we can find 0 at this point. We can say the concentration of zinc and copper remains constant, it do not changes. So here by substituting these values, look at this, at the point of equilibrium, so at equilibrium E cell value is 0. So when we are saying the term equilibrium, then the concentration of product by concentration of reactant, concentration quotient can be considered as Kc. Equilibrium constant क्या है? Equilibrium constant, reaction quotient at equilibrium, Kc is equals to Qc. You have written Kc is equals to Qc at the point of equilibrium, where this Qc is nothing but what? Kc is equals to concentration of product by concentration of reactant species. This ratio is taken as Qc. So here I can write at the point of equilibrium, ये दोनों ratio के जगह I can write Kc. So therefore, when E cell is equals to 0, ये जो Daniell cell है आपके पास, E cell is equals to 0. When this values becomes 0 at the point of equilibrium, ये अगर 0 हुआ तो क्या हो जाएगा? E naught cell is equals to, ये माइनस चार्ज इधर आएगा, E naught cell is equals to plus 0.0591 by n in general. For Daniell cell its value is 2 into log of these two species, and इसके जगह हम Kc ले सकते. So the same thing I have written. Look at this. The equation 1 becomes E naught cell is equals to 0.0591 by 2 into log K, and in general for any reaction, this is the cell equation. E naught cell is equals to 0.0591 by n into log K. So in order to calculate the value of K, equilibrium constant, how we are going to calculate the equilibrium constant? By rearranging this expression, right? So rearrange this expression. Log Kc is equals to, this n is multiplied with this, so n into E naught cell divided by this term. So log Kc is equals to n into E naught cell divided by 0.0591, right? Or else by taking the antilog we can find by remove. By taking the antilog we can cancel this log by taking antilog. So therefore Kc is equals to antilog of this term. So dear students, you note this expression. Equilibrium constant from cell potential that is log Kc is equals to n E naught cell by this, or else simply you can write E naught cell is equals to 0.0591 by n into log Kc. So here they will provide the value of E naught cell and they'll ask to find the value of equilibrium constant and vice versa. If equilibrium constant value is given, then they can ask this value also. So here let's go with one problem. Simple problem है यहाँ पर. Problem आप खुद solve कर सकते हैं आप यहाँ पर. NCERT का problem है. So देखिए यहाँ पर calculate the equilibrium constant of the reaction. They have given one reaction. They are asking to find the equilibrium constant Kc for this expression. Given E naught cell is equals to this. So how to solve the problem? Simple. What they have given? So you can write the given data first. Given is E naught cell. E naught cell is equals to 0.46 volt, right? Okay. And Kc is equal to question mark. Equilibrium constant is equal to question mark. What is the relation between these two terms? We have the formula. E naught cell is equals to 0.0591 by n into log Kc. So I want to calculate equilibrium constant. This value is given 0.46. That is equals to 0.0591 by n into log Kc. So what is the value of n in this equation? ये equation में n का values कैसा find out करें? तो आप देख सकते in this expression copper ion undergoing oxidation, it gives raised to +2. That means how many electrons is lost? 2 electron. Total number of electron lost or total number of electron gained, that we need to consider. So n is equals to 2 हो गया इसका value. If you are considering Az, तो Az plus is converted into plus 1 electron converted into Az. So here 1 electron, but in the equation they have given 2 Az plus ion. So 2 Az, 2 electrons, 2 Az. So number of electrons involved is 2. Either from oxidation or from reduction. N value is equals to 2. So 0.46 is equals to 0.0591 by n. N value is 2 into log Kc. So here I want the value of Kc, therefore log Kc is equals to 2 into 0.46 divided by 0.0591. So simplify this equation. Mathematically आप simplify करो, कितना आता है इसका values? Its value is 15.6. This is log Kc. And antilog, if you want to take the antilog values, this value is approximately 10 to the power of 0.6 into 10 to the power of 15, right? You know how to find out the value of log and antilog. Log and antilog कैसा लेते आपको पता है? So here 15.6. So its value is in the order of 10 to the power of 15. So therefore Kc is equals to 10 to the power of 0.6 into 10 power 15. So what is the value of this? Approximately you know that 10 power 0.6 है, 10 power 0.5 रहा तो root 10 is approximately 3.1. So here 0.6 तक है. So कितना आता है यहाँ पर? 3.9 approximately 3.9 into 10 to the power of 15. So if you don't know the value of 10 to the power of 0.6, you can remember one value. 10 to the power of 0.1 value is equals to 1.2586. So this 10 power 0.6 can be written as 10 power 0.1 into 10 power 0.1 into 10 power 0.16 times. So that is 1.25 into 1.25 into 1.25 into 1.25, like that you need to multiply it by 6 times. So its value is approximately 3.9 into 10 to the power of 15 is the answer, equilibrium constant Kc. So here this is one. The next concept is relation between relation between electrochemical cell and Gibbs energy of the reaction. Relation between electrochemical cell and Gibbs energy of the reaction. So as we know that electrical work done in 1 second is given by electrode potential into total charge. Electrode potential is represented by E, total charge that is N into F, E naught. potential, electrical potential है, so in our it is multiplied by directly proportionally. So n E naught, electrical work done in 1 second. in physics के concept में हमको पता है ये value relation. Electrical work done in 1 second is given by electrical potential into total charge, right? Now to get the maximum work by any galvanic cell, the charge must be passed reversibly. तो charge है reversible pass करना पड़ेगा. So the reversible work done is given by, that is equals to decrease in the Gibbs energy. Now what is the definition of this Gibbs energy? Thermodynamics concept. Gibbs free energy, we have defined the amount of energy, the maximum amount of energy or the free energy available to do the useful work. The amount of energy available to do useful work is Gibbs energy. So here Gibbs energy is proportional to work done. Reversible work done is nothing but decrease in the Gibbs energy, and it is given by delta G is equals to minus NF into E cell. Note this expression, ये equation हमको चाहिए. If the concentration of reactant species is 1 molar, then we are going to use delta G naught is equal to minus NF into E naught. Okay, minus NF into E naught. And in this expression, where this N is number of electrons involved, F is Faraday's constant, where this N is number of electrons involved. F is Faraday's constant, its value 96487 accurately, or simply we can use 96500 coulombs. 96500 coulombs. Here you can find E naught cell or E cell electrode potential जो है, this value is intensive property, whereas delta G is extensive property. Now recall the definition of this intensive and extensive property from thermodynamics. Intensive is nothing but, intensive property is nothing but independent, right? Independent, I, intensive, independent. Whereas extensive property is nothing but, it is dependent. It is dependent, independent and dependent, because look at this. E naught cell, it is independent on the quantity of substance, whereas delta G is dependent because it n values varies. N values क्या होते हैं यहाँ पर, vary होते हैं. For example, for the Daniell cell, if you are going to consider, in this case n value is equals to 2, therefore delta G values क्या होते हैं, minus 2f E cell, right? Suppose if the equation is multiplied by 2, then n is equals to 4 आ जाएगा, delta G का values change होते हैं. So delta G values is dependent on n. So delta G values क्या है, it is dependent on n, dependent, therefore it is extensive property. Whereas E values is independent, E value is independent, it is intensive property. Please note this formula. So in general, in total, we have the 3 formulas. One is Nernst equation. Second one, relation between electrochemical cell and Gibbs energy. And one more, relation between equilibrium constant and Nernst equation or E cell. ये 3 equation में आपको numerical ज़्यादा रहेगा. You need to solve many problems on these 3 expression. They will ask different types of problems, variety of problems on this. Even in NCERT, in text as well as exercise problems are there. You go through that and solve many more problems. So here one problems I have selected. The standard reduction potential of a cell is given. The cell potential of a cell is 1.1 volt for Daniell cell, and they are asking to calculate Gibbs free energy. Gibbs free energy. NCERT problem, a simple problem. So delta G is equals to, they are asking calculate delta G now. Delta G, Gibbs energy. So first step, what we want to calculate, Gibbs free energy. So write the formula for this, NF E naught cell or E cell, if standard. So now I want to calculate delta G. So I require these 3 terms. In these 3 terms, they provided the 1 values, that is E naught cell. E naught cell value is 1.1, right? E naught cell value is 1.1, it is given. Now, so we have to find out the values of these 2. So here in Daniell cell, n value is equals to what? N value is equals to, yes, right, it is 2. How? Because Daniell cell, zinc undergoing oxidation, copper undergoing reduction. Zinc undergoes oxidation, Zn2 plus 2 electron, N is equal to 2a. Okay, F, Faraday constant, its value 96500 coulombs, or accurately you can use 96487 coulombs. 96487 coulombs. So substitute these values. N value is 2 and F value is 96487 coulombs. E naught value is 1.1 volt, 1.1. सो मल्टीप्लाई किया तो क्या मिला आपको, टोटल वैल्यूज कितना है यहाँ पर 2 इंटू 1.1 इंटू दिस, सो इट गिव्स रेज टू अप्रोक्स 21227, दैट इज इक्वल्स टू 3 डिजिट बैक आए तो 212.217 किलो जॉल्स पर मोल. डेल्टा जी इज इक्वल्स टू 212.27. मैथमेटिक्स से जस्ट आप मल्टीप्लाई करके कैलकुलेशन करके देखो करेक्ट है या नहीं. सो सिमिलर प्रॉब्लम्स यू नीड टू सॉल्व ऑन दिस टाइप. सो नाउ इन टुडेज सेशन वी हैव कंप्लीटेड the two relations, important relations. One is electrochemical cell and Gibbs energy, and one more is equilibrium constant from the Nernst expression. In the last session, Nernst equation for single electrode and for a cell we have discussed. So among these three you need to solve many problems. So this completes the first half, that is part 1. Electrochemical cell we have completed. In the next class we'll move to the next concept, that is part 2, concept of conductivity. We'll study in the next session.